Anjali, right? ANGLLI.
Not LLI.
ANGLI underscore DODDA at yahoo.com. Oh. Okay, so I'm allowing everybody to record. Okay, let's get started. First, let me. So, what is the last topic we discussed? We discussed around GridSearch. Need to tell again, or I haven't discussed it. GridSearch.
Not in detail, just introduction.
Oh, what is GridSearch? Okay, I'll start with what is GridSearch. Okay, I was trying to mute her. She was trying to mute herself. Okay, let's understand grid search, which is apparently one of the most important topic in identifying hyperparameters.
Project 11, that one. The last, in project 11, that is the last one.
Project 11.
I mean, that is the one last.
Oh, okay. Let me grid search. I didn't speak much, right? So let's understand what is we understood. So let me revisit what we have learned now. Let me know. So we understood what is linear regression. We understood how to do polynomial linear regression, right? We understood how to do classification, right? Okay. We understood how to make use of pipeline, right? We understood how to calculate accuracies, right? What are the accuracy calculating technique for classification? Accuracy score, right? What are the accuracy calculating technique for linear regression? R2 score, then mean square, error square, and all those techniques are there. And for classification also, you have confusion matrix. We understood how does confusion metric works. Then we saw there is something known as accuracy score, confusion matrix, F1 recall, right? F2 recall, precision. I mean, there are a lot of other techniques. Okay, I mean, this is just one. I mean, when you say something is accurate, you say it with respect to some call. So, okay, let's see now. To build on top of grid search, how to use it. Okay, and whatever code we have written earlier, we'll try to make it simpler using grid search. Okay.
So what we discussed right now, we discussed on structured data, unstructured data.
Unstructured data, you first have to convert that into some structure, then only you can do this process. Got it, right?
The social sites, what we got, right? That
I'll tell you how to do that. Okay, good that you brought that up. I'll tell you. So how you do that basically is you make use of map. Okay, map, and then convert each row. There will be a dictionary sort of a thing, right? If you see, you will have fixed number of columns, and one of the rows sometimes will have, one data, sometimes will have 10 data as a dictionary. How to process that? Okay, that sort of operations we can do. Okay, maybe I can show you one example using that. Grid search, huh? Seeing my thing. Okay, so grid search. What is the purpose of grid search? Using grid search, what you do is you basically find out what important hyperparameters. Okay, that is one basic purpose of grid search. The parameters that is required to initialize a model. Like in case of linear regression, it is fit intercept that you pass. In case of KNN, right, you pass nearest neighbors, some numbers, right? These are model initialization techniques, right? Okay. So one of the use case of grid search is you find out what are the initial parameters that are required.
Same as the tuning parameters.
Same as the tuning parameters, absolutely. These are what are first let's understand what is hyperparameter first. Hyperparameter. Okay. Okay, so sklearn model selection, import grid search CV. Okay, so let's first create some hyperparameters, then we'll create some pipeline. Okay, import bias. Okay. Then we'll solve some problem using grid search. Okay, which will consolidate the learning, the entire process. Huh? What are you doing? You're importing NumPy here. Okay, then yeah. Okay, then I'm hopping few lines just to minimize the code writing. So see here. Okay, so what we are trying to do in this example is earlier we saw using we used different degrees. We used different parameters of linear regression. One is fit intercept, other parameter is normalize. These are your parameters of linear regression. I will show you. Okay. If I do help of linear regression, you see here, one is fit and intercept and another is normalize. These two parameters are there, right? Okay, so if you do linear regression, this is the class name, you are putting it like this, underscore fit intercept, who is one guy, normalize another guy. What are the possible values? Here the possible value is Boolean, here also possible values is Boolean. So that is why you are configuring with true, false, true, false. Then you have polynomial feature. If I do polynomial feature, the one parameter of it is degree.
Yes. 0 to
degree, see, right, it is the integer value. So you are configuring the class name, understood, right? How the architecture is dictionary. Okay, how you create the grid is param grid is the class name and underscore the parameter name, and you are giving your possibilities. Arrange 21 means 0 to 20, right? Say true false means there are two possible options. This guy is two possible options. You are giving all possible values because you don't know which one is better for you. Okay, you don't know which one is better for you. That is what you're trying to do here. Now, Okay. Now what will you do? We'll try to create a pipeline. In this pipeline, we'll have same as polynomial features, okay, and a linear regression. Okay, you can see here what you have is where this is a what you're doing. You are creating this is a polynomial regression. This is a function. What does it by default takes 2, but of course it can have any number of degree, right? Then and correspondingly a polynomial feature will work. Okay, then you have this guy kw variable parameters. This is like you're creating that pipeline here. Okay, what does your pipeline consist of? Your pipeline consists of transformer, okay, and estimator here. Okay, now is the magic. Now in one line I will create a grid search CV. First give the function get the pipeline from here. This will be pipeline here, right?
Yes.
Okay, and next you have to pass all the parameters that you want to pass in the pipeline. Done. Oh, what happened?
Parameter.
Param grid, I think I didn't execute it. Yeah. Okay, so it passed all the parameters here. This guy is ready now. Now you can actually find which is the as I was using earlier. I'll generate some data, not use some existing data. This I want to show something. Okay, what I'm doing, I'm generating some x and y here. If you want to see x, it looks like this. This is the same data that we have used before, right?
Yes.
X, and this is your y. Okay, don't worry about the data. We have some x and y prepared for us using this function. Random. Now what we want to do? We want to train the model. Okay, what is our model here? This is actually I'm not using it. Just wrote it for that case. So this is our everything, right? What is grid? Grid consists of everything. What are the possible options? What are the possible values? Okay, all you do is grid.fit x comma y. Boom. It will try for 21 degrees. It will try for everything. But the question that will be in your mind is, which one is better? And if I tell you that can be obtained with just one line, okay, how would you use it? Grid dot best parameters. This is the best parameter. Degree 4 it is working best.
Okay.
Fine, right? Degree 4 it is working best. Normalize false and fit intercept true. If you want to get access to the model so that you can the best model. Remember earlier how we did, we stored it and all that. If you want models is a two-step process, lighting all those code. I mean, that was necessary to understand how it is working internally. But if you're a pro, data scientist, you'll not do those stuff. You'll do this. It's done. You got the best model. Now, if you really want to test the data, this is your new data that you have created. Fine, right? You got the output. So it's very simple. It has become now very simplified, right? You don't have to write that complex degree code and all that. Right, in one shot you can do. Okay. Now let
Avantik, one level of understanding for me is in the previous class we find for a linear regression we find the baseline fits for the data. So with the GridSearch it will give directly the best line. Is it so?
Right. You will directly. You just have to tell it all possibilities. It will do everything internally and give you the best possibilities.
So for a given data, how many possibilities possible? How we can get the things? given data, there are infinite lines in a hypothesis. There are many lines possible for a given data, right?
Mm-hmm.
So how to find these many lines are possible to predict?
That's what you did here, right? You configured here, right? You gave here, okay, try till from degree 1 to degree 21. Try
Okay.
with all these values. Give me the best value, true or false.
True or false.
Right.
Okay.
So as a problem solver, you typically have to do some experiments around it, right? And it will all done.
True or false? That is fit intercept. It will be default as true.
Default is, I think, true.
I guess the description there for fit it's true and normal is
False, right? So that is default value. As of now, we have been using with default value, but non-default value can give us better result at times. Okay, that is why you give all possibilities here, so that you can try and test for all the combinations and give you the best result.
If it is false, what will happen? Intercept will not be there because theta plus, so that theta will not be there.
Yeah. So one thing is, it will not use. It will try. I mean, if it is complex line, right? If it is complex line, suppose 5 features are there. Ax plus by plus cz plus 5 features are there. There will not be any intercept. Okay, that whatever you are saying, right? This intercept part will not be there.
So what linear regression fit intercept true false means? What it will take, true or false?
That's what it will try for all possible combinations. It will giving you which one is working out best, right? It is giving here that fit intercept true is best for this particular data.
Okay.
Normalize is false for false better, and number of degrees 4 better.
But in that case,
So
the formula for the line itself is wrong, right? If intercept is not there.
No, nothing like that.
Mx plus c, and if c is not there.
No. This you are considering very straight simple line. If you have a 10 variable line, the equation of line be ax plus by plus cz plus blah 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 blah, right? In that case, anyway, intercept may not be doing good. I mean, it is trying with intercept. It is not trying with intercept. So it's not that. In that case, c is equal to 0. That is what it means. No, not necessarily. Fit intercept, when you're telling fit intercept is equal to 0, I mean, this false, it means that it is not trying to find c. Okay. So in case of, don't just compare it with one straight line. Okay, compare it with this guy.
Anyway, it's one time it's giving false. The another time it's checking.
It might be.
True also it's checking.
Might be. Okay, just the thing is, it's very difficult to tell this without testing it, whether it will be, you really need fit intercept to be true or false. Okay, so you need to do both the experiments. What is happening here, you don't have to do all those things manually by yourself. You just tell it this is one field, that is another field, and it is taking care of it by itself. It will try with true, it will try with false. And no, listen. It will try with true. It will find how accurate is your algorithm. Okay, and we can see here the accuracy of the algorithm also. I think pass the data here a second. Grid, right? I think it was error score. I think it was showing you that. It will give you that score. I think best score. Yeah, sorry. You see, the score is 91%. So what it is doing for every model, it is every combination like degree 5, fit intercept false, and normalize true. For that combination, it is finding the score. For all possible combination, it is finding the score. Okay, then it is telling you, boss, this is the best combination. Understood, right? Okay, so fit intercept means that intercept is, I mean, you have infinite such combination, right? What you do is you run for all of them.
We can pass another data so that it will give another.
Of course.
System. No, we'll be seeing if we pass another data now itself. I mean, you generate the another sequence of data and just pass it so that it will not give the gradient of 4. It will be giving 5 or something else.
Oh, that way.
I'm just
right.
for an example.
Right. We'll do some examples around it, but got the concept right. What is grid search meant to? Grid search is meant to get you the fine tuning. I mean, it is supposed to get you. You are doing it for, you as of now we are doing it for only polynomial features, right? Sorry, only mean regression. You can try here different models also, right? You can try here different models, and it will find the best model among them, which is best.
What is normalized?
Normalization is generally linear regression faces this stuff. We'll see it in advanced courses actually. So you have something known as what is normalization concept to handle outliers. Your data set sometimes have outliers in it. Okay, what is outliers? Suppose you have house price prediction you are doing. Few houses you see it's very good house, but some due to some emergency they have to sell it at very low cost. This sort of data, right? This sort of data will be impacting the machine learning algorithm if they are taken into consideration. So what you need to do, you need to get rid of such outliers. That is what is called normalization of the algorithm. It's not really filtering the outliers. It is really making the algorithm robust enough so that it can handle such outlier case and still give you a good predictability of the algorithm.
Also, it is not considered the outliers. It doesn't handle it properly.
Normalized positive is by default saying no need to. The data is pretty much on the around the straight line, so no need to normalize it. Okay, there is a lot of techniques here. Lasso. Okay, I mean it after that, beyond this it goes very deep, like not a normalization technique and all that are there. Lasso, ridge. Okay, these are your advanced regression techniques. Okay, at this point of time, this is where we end here. Understood, right? If you take up a problem, what are the parameters, pass on the parameters, use it to create a pipeline, see the results.
Hello, Avantik, could you please, I couldn't get what is the normalization of a model. Could you please repeat that thing?
Okay. So what you have here is few outliers in your data. What is outliers in your data? As I was giving the example, you have some houses sold at very cheaper rate, but you do not want your generalized algorithm to be impacted because of this somebody selling their house cheap. Because the average cost of house has not gone down. Somebody has sold it maybe because of dependency, right? So this sort of data are always present. Okay, and if you are doing linear regression, this is what normalization means: handling such cases. Okay, you want your algorithm to be normalized so that your prediction is not impacted by such outliers. Okay, that is normalization. So there is such infinite configuration parameters. Okay, just know how to use it. Okay, have some basic idea of it, you will be able to solve from. That is what we are trying to focus on, right?
So is that same as the normalization in probability?
Normalization as such worldwide has same meaning, right? I mean, it is to if you plot a graph, anything, it will have peaks. Normalization means setting it, pulling it or down, right? I mean, what do you say, flattening it, right? That is what is normalization. Okay, so you can take any area. I mean, it will eventually mean these things. So in this case, what the outliers is coming outside, right? You want to flatten it out. Okay, just
okay. So all the model working on normalization data, right?
Right. Okay, these are some fine tuning stuff which takes your accuracies from 85 to 90, 90 to 95, that sort of stuff. So let's see.
This hyperparameter is no different than the
True false, yeah. You can actually provide much more things around it actually. Okay, true false. You can see for polynomial degree we had various such options, right? Okay, so we understand now grid search. Okay, now Okay, so these are, I mean, few posts that are already there. So today's assignment will be to, this is, remember last time I shared a problem, predicting number of comments a blog will receive. Okay, so the solution is here. I want you guys to try, then you can, cross check with the solution. Okay, this is a very less optimized solution, but still something around late 80s. Okay, so I want you guys to use this. But you can, of course, with just a simple fine tuning, you can make it 95s. It's possible. Okay, so we understand now these aspects, right? Okay, so in featureization, we have studied about label encoder. We have studied about this guy. One thing I need to show you guys to convert into columns. We use label encoder as of now, right? Now, two things I need to show. Okay, I'll explain you. Okay, before we proceed further in dealing with text, we did TF-IDF, right?
Yes.
We did TF-IDF. We did vectorizer, but we didn't show you how to do that in a content. Okay, so I'll show that case. Okay, and one hot vector. So next time when I do some analysis, okay, I'll use one hot vector and dict vectorizer. Okay, to complete it. So as of now, any doubts in the entire journey so far? Given a problem, this week you tried some, I forgot asking. Huh? She hasn't done it. How about you? You did it? Okay. No, don't do that.
Regarding that neighbors,
Uh,
is it only for the probability design?
Neighbors is for classification.
Classification,
Right.
but as I remember, it is used for only for the probability. I think someone.
No, it is fundamentally using probability concept and all that. Okay, but the output also you get as a probability. Okay, I mean, if you do predict proba, model.predict proba, right? You'll get probability of how much percentage this particular data is getting classified into this particular class. Label encoder is converting string data to, like, male female is the label encoder, convert into 0 and 1. Okay.
I tried this, making function when you were using function to just input the data, will get the output. Right? I was trying that, but the accuracy is coming to put it like when you commit like.
What is coming to anyway?
I mean, the accuracy. Because I tried to make a function for everything. Data you get output. So in that case, the accuracy is coming very less.
Oh, somewhere wrong.
So it depends on data mining and data cleaning.
No, there must be some other thing also.
In that parameters which you pass, the feature parameter, you might have changed it.
No, it's the same thing.
You tried all changes, still the same.
Very 23 minus.
Okay, we'll see that. Then one hot encoder is there, which will convert numbers to a vector of 1 and 0. Numbers to vector of 1 and 0. One hot encoder. Okay, just keep in mind, one hot encoder is which will convert. Suppose your one column is there, which is a fixed number of numbers like 5, 17, 1, 2. It can convert this particular data into a vector. That is a vector of 1 and 0s. Like 17 is there in the column, so you will have 70. You will create from that one column. You will create 17 columns, and 17th column will make one, rest other 0. Okay, we'll use it one hot vector. It will be clear. Okay, just keep me reminded if I'm using. Okay, you can see the content now. Okay, I'm just want to see this. So we have done a few things around hyperparameter model validation, featureization. Feature engineering was all about you're converting data, string to numbers to all those. Then you have logistic regression, right? Then you did something around naive Bayes. Naive Bayes, we do that 20 data, 20 categories, male categories.
No.
The naive Bayes, we didn't do much of stuff, right?
One time we used just classification. That is for iris data.
Oh, okay. So
only one shot.
Right. So I'll do a complete program using naive Bayes. Okay, right from scratch to end the entire data processing activity. Okay. After that, later on we'll go to k-means. After that. Okay. First, let me do a complete project using naive Bayes. Okay, so first let me load data. I'm loading data from some inbuilt data actually.
Page or is it not updated? Page not there, see, it is old one.
Which one? Oh,
Content.
is it?
Yeah, no, it's correct.
Okay, interesting. Now, can you see my new page?
What's disconnected?
Okay. So now we'll do text, working on text data using namebase. This is a very good exercise to understand few featureizing concept and few things around the text data. Okay. You have to do comment, review comment analysis using this same process. Amazon food review comment analysis. Huh? Okay. Text. Classification.
Using
This is
so you are importing data from Skyline.
scikit-learn. This is good amount of data actually. Okay. Now what we want to do, we want to divide this data into train and test actually.
10.
Not really 10, train and test data will divide. Okay, inbuilt functions are there. Okay, just so that I don't have to. Yeah. Okay. Categories. Okay. Now, actually, we need some categories because this data has a lot of categories in it. So, okay, so let's first see the categories of data. Wait. Oh, it is downloading the entire data set. Oh, this is 14 MB, right? Should be doing data is equal to this. No. Right. If you do data dot
Info.
Description. Description will be all the stuff. So if I do data, it will be, oh no, I forgot. It will load the entire data now. Wait.
No, for describe it will not give.
Yeah, so we wanted this it is a little bit stuck for a minute. So you can see here we have a lot of data. Okay. If you want to,
Still not with the base.
Oh. It's showing refreshed.
It's a bit slow.
Oh, your thing is slow. Okay, so this is this, So data, if you do, okay, it will be list of all information.
Data about
Data is a keyword or?
No, it is a dictionary which contains everything. Or this data is a field inside it. It is list of all information actually. Okay, then you have target also.
What this dot data will know?
It will show you all the data. Okay, so give me 1 minute.
Okay.
Let it come. Okay, so if you, this is a lot of data. So actually this is a little huge data. So every time I do this, it will choke my stuffs. So I'll make it a little simple actually. Okay, here when I'm fetching the data, right? I want it has. Let me see if I can do one last thing. These are the possible categories of data that I have. Right? I mean, a lot of data are there. Just visualize the data. A lot of data are there. Each data belongs to one of these categories. Fine, right? This data you've done?
I guess. You only ask no God for sale, which classification it comes into it.
God or
God for sale, which classification it comes
oh. Then yeah, that's what I was asking. You know, you did using namespace or what?
into, I guess. Maybe for that only.
Maybe once we did the areas, but not sure, not in a very deep level. We just showed it.
Only one set we have used. I guess maybe for this only.
Okay.
For this only confusion matrix also we have done.
We have plotted everything.
Yes. He asked a couple of times confusion matrix,
Confusion. No, you're there. Now I remember. That's okay. That's okay. Let's do it quickly. Okay. Now that since you guys know the data, so I'll just quickly do it. Let me know if it is confusing at any point. Okay. The reason I want to do quickly because we can do some more new things. Right? That is the sole objective.
Otherwise, we can take any other data sets.
Yeah. Okay. So classification wise, okay. Since we have done it, actually I'll not repeat it then. Okay, because I would have done the data same day text processing and all those things. Okay. Maybe I can. But prior to that, in that case, what would I want is I would want one more algorithm like decision tree and all, so that we complete 3-4 classification techniques. Okay, then we can find out. We'll do classification on employee exit. I think classification. Right. We have done right.
Last week only.
Oh, I'm forgetting. Then we didn't do random forest and all those.
Yeah, that is we didn't. K means also we didn't.
K means okay. Done till this point actually completely. Okay, so
Naybase, huh?
Naybase, yeah.
No, but it's just for use.
You didn't explain.
You didn't explain. What you said is you just
did this example.
This thing.
Afterwards, I'll
tell you what.
Okay, that is what. So tell me that. So what happens in Naybase? Okay, I can show the previous stuff. What happens in Naybase? You understood that this is for classification.
Yes.
Right. And multinomial NB, if you're using for multi-class classification.
Yes.
Right. And the other thing that you have a Gaussian MB, that is for by classification mostly that you can use. Okay, so that means two classes. Okay, so I'll write it down here. Gaussian.
I mean, only two classes.
Only two. It's more suited for two classes.
Two classes, like
yeah. More suited for two classes. Right. When I love cancer. Right. And multi. Okay, so you have Gaussian NB, you have multinomial NB. So these two variations are there. How is Naybase generally works? Okay, now you earlier saw how to use it, which is not much different. But how it works, right? It works. Let me give an explain. Did I explain the Gmail example? No, right? Spam, right? Okay. So what do you? Okay, so what happens over there is, see, there are two things here. First is when you're a mail is coming to your directory, right? When a mail is coming to your directory, what happens? Either you mark it as spam. First time when your mail is coming, you mark it as spam. What does it do? For each of what it finds out, it finds out probability of that mail, of each word being part of that spam mail. Okay, for example, suppose today you are getting a mail, you are marking it spam. There are some words in it. Okay, what it calculates, the machine learning model. I remember each of you has a different machine learning model for your Gmail. Okay, your machine learning model will calculate what is the probability of each word being part of a spam mail. Since you marked already the mail spam, right? You'll find probability of each word based on the previous probability and the probability of this mail, right? And next time onwards, when a mail is come, first it tries to predict based on the previous probability that whether this mail is spam or not, right? How does it do? Each word's probability it has calculated earlier, it tries to do a accumulation or summation of all those probability, all those words. Okay, all those summation, that means there was probability of good, food, free, all those things are there, right? Which it has calculated in the past. Now it will do summation, not really addition, but it will do summation. That means there will be some operation, a mathematical operation which you'll do the summation, and you will find a cumulative probability of that mail becoming a spam, being a spam. And that is what if that is more than some configured number, it will mark that mail as spam, otherwise it will not mark the mail as spam. Okay. That is for naive-Bayes. This is the naive-Bayes concept actually. Now Gaussian and multinomial NB, just a slight modification. Okay, how does it work is the multinomial MB has some internal tunings done so that it is more suited for multi-class stuff. Because none of these Gaussian MB, multinomial NB, these are not by default suited for multi-class. It is generally by class. By class means how it will identify if something is for two. Suppose you see your current mailbox, a 4 categories: spam, primary, social, promotion, right? 4 categories. Now, how does it work? Basically, first, I mean, if it is with naive-Bayes application, it will first divide your data into mail into 2 parts. I mean, okay, spam, not spam. If it is the first stage, next stage, the not spam mail it will take. It will divide into primary, social, promotion. Naive-Bayes. So it will do actually every stage it will do it with. Suppose it has not.
Like it will split
into 2 parts. Actually. First time it will get not spam, not spam. Not spam it will get primary, not primary. Not primary it will get social, not social. And later on you decide social. You'll say social promotion. Understood, right? So it is trying to implement multi-class using by-class only. So multinomial, see, these are mathematically little internally different. Okay, because of which we use different algorithm for different cases.
What is the first hierarchy? What is the first
you don't have to do all these things. Okay, if you are a data scientist, your role is typically you should know that if it is by-class, it is Gaussian. If it is a multi-class, it is multinomial NB. Understood, right? Because multinomial NB is more suited for multi-class classification.
Naive-Bayes and Gaussian both are same.
Naive-Bayes is and Gaussian and multinomial both has NB at the end. Gaussian naive-Bayes and multinomial naive-Bayes both are naive-Bayes.
Naive-Bayes is
Two guess, yeah.
Naive-Bayes, what is this Gaussian Indian multinomial?
Gaussian NB and multinomial NB are derivations of naive-Bayes. Naive-Bayes NB is nothing but naive-Bayes.
So how they do? No.
They didn't divide as such. Gaussian naive-Bayes has 2 types. Sorry, naive-Bayes has 2 types. One is Gaussian naive-Bayes, one is multinomial. Gaussian naive-Bayes is more suited for two. I mean, it is based on some algorithm which is more suited for bi-classification. Multinomial naive-Bayes is suited for multi-class classification.
Again, multinomial.
When you're training the data, when you're training the model, if your model has multiple class output, then it will be multinomial NB. Example like the mailbox that I gave.
I already wrote it like this. So is this tree structure correct?
This is multinomial naive-Bayes.
This is multinomial.
One more example I can give for multinomial, multi-class classification is health of a system is good, bad, or it's completely English.
No, still not sure. Gaussian and multinomial are not.
No, this is how internally it works. What I explained.
Oh yeah, this is which one? This is multinomial.
This is multinomial. Yeah.
Then what is Gaussian?
Gaussian is also similar to this. See, it's not that one algorithm can do something, other cannot. Okay, it's like car. It's not that one car cannot. I mean, if you have a big vehicle, it cannot run on road. That it is more suited for this application. Understood this, right? So using Gaussian naive-Bayes also you can do multi-class classification, but multinomial NB is more suited for multi-class classification.
But there is one feature which these people. So
that's what I'm saying. Multinomial NB is more suited for multi-class classification. Gaussian NB is more suited for bi-class classification.
only to do with the division.
Yeah. It's having said that, I do not mean that you cannot use Gaussian naive-Bayes for multi-class classification. You can do that.
Maybe can you play with this? We make spam not from that's all. That is Gaussian.
See, it's more suited for. I mean, don't draw very hard lines over here. Okay, it is more suited for it. That's how when you're training the model, when you're running the stuff. Okay, you will use both of them and see multinomial NB is doing better if it's a multi-class stuff. I don't know how much you are able to follow because it's just middle of the class today. If you want, you can. I mean, it might be a little torture for you.
Avantik, this is a mechanism or procedure to identify the uniqueness in the feature, right? In a class, or
you're saying Gaussian NB and multinomial NB.
Just naive-Bayes. I mean, naive-Bayes. Gaussian is a normal distribution, right?
Right.
Yeah, and
naive-Bayes, the purpose of this Gaussian naive-Bayes, I mean the purpose of this is to classify data actually, right?
Yeah.
Given a data, you will be using these techniques to just classify them. Say which class does it belong. Okay, so earlier we have seen logistic regression, right? Then this is one of the other techniques, naive-Bayes. Okay, you have two derivations of it: Gaussian naive-Bayes and multinomial naive-Bayes. Okay, just put it in two simple words. Gaussian naive-Bayes is suited for two classes. Okay, and multinomial naive-Bayes is suited for multi-class classification.
So you can only use for that text, or like we can use for numeric.
You can use for numeric things.
Then how the linear and
these things are right now. So here logistic. Okay, yeah. So here multinomial NB, this takes very less initializing parameters. That means this naive-Bayes algorithms takes very less initial parameters. Okay, since it takes very less initial parameters, this works decent for any complex data. Okay, or for any text data, it is relatively fine. Okay, naive-Bayes. So whenever you're doing some text data analytics, text data, some some huge number of rows data is there, it needs very less initial parameters. It works good with that.
So you meant to say for text mining, text classification, naive-Bayes is good for that.
Text classification, you get generally get good results. Okay, and what is your question?
Now, how logistic and it differs in the way it takes.
So logistic, what you do is you try to create a line there, isn't it? Here you are not creating a line.
You just cumulative
probability based probability, you are separating it out.
Bell curve.
Right.
So this is a cancer one you're telling a and malignant. So in that case,
it will find the so
cancer and non-cancer.
Yeah. So that is how
So this is Gaussian NB. Gaussian NB example.
Right. You can just Gaussian NB, you can use it, and see, you have to, given the problem, right? Okay, there is certain intuitions that you have now, right? That it might work good, but how do you confirm which is the better? Try it out. That is the best one. Let's see. Okay, that is why your concept of pipeline, those things. So these are algorithms suited for different use cases, different situations. Many times you might know the data, many times you might not know the data. So why leave it to the chance of knowing the data? You can try to do both best, right?
But one thing, to use these algorithms, right, the procedures, we should know the data. We should understand the data, right?
Right. You should understand.
Without knowing data relationship, we cannot apply this the law.
And to add something to that, sometimes you use machine learning just to understand data as well.
Yeah.
Okay, so it's not always your data. You need to understand data first and then do apply machine learning. You sometimes apply machine learning, like in case you apply this naive base. This is working with naive base. That means that means the data type is something that is suiting naive base. Then you understand this data is naive base type. Right. So having said this, I definitely showed a diagram earlier which you do this first, but sometimes there is a loop there as well. Okay. So okay, so got a hang of this, right? Naive base. So let me do one example which includes both naive base and maybe naive base. Okay, and we can yeah. Okay. Okay, so there are a few projects that we think we should be.
One question is there. The thing is that do we suppose we have a sensor data. So for that, for a given sensor, we are having a data, and we have to classify whether it is it is good, bad, or partially good. So maybe is good for that, or some other algorithm is good for that, for a sensor data, for considering sensor data.
So if it is very naive base generally gives a very, actually have some, just a second. Okay, there are some, checkpoints on naive base. Naive base is very simple algorithm which gives a decent result on complex data. Okay, so you can see my stuff here. Okay, so when to use naive base, right? Extremely fast for both training and prediction. This is the first point. Very few tunable parameters, right? Provides probabilistic solution.
Still loading.
Okay, so you guys are able to see my screen?
Yes.
No.
See, but not the current page.
Not completely, but I can see when to use that thing.
Yeah. Oh, it's still coming to you. I think here it is slow compared to.
There is, this internet is a bit slow.
Oh.
Last meeting itself is lost.
Yeah. So I think everybody can see this.
No. I lost.
Oh. Okay, Joe, doesn't matter. So first, just text I will read. So it is extremely fast for both training and prediction. Okay, because of the simplicity it provides. It is a good benchmark solution. That means if you want to do some classification, naive Bayes is definitely a good benchmark solution.
For text classification.
Yeah.
For
And even normal classification as well. Text classification is more used. Okay, and it gives good results. But having said that, you cannot say that it is not good for normal classification. Then you have very few tunable parameters. Your algorithm, if it takes very few tunable parameters, that means a lot of parameters it is trying to predict from the data itself. Right? A lot of data it is trying to predict from the data itself. Okay. Then you have then it provides probabilistic solution. Right? Probabilistic solution means it will using this. I mean, if you okay, you can find out if you do predict proba. Okay, if you do predict proba, it will tell you. It's not showing up. Oh. I'll put it here.
Both the statements. Not friends.
Predictable.
No.
Yeah, they are twins actually.
Friends,
okay, friends. You can fine tune your algorithm.
Sancho?
God intends will go far
Behind your imagination.
Extremely fast for both training and testing. Very few tunable parameters and provides probabilistic solution. Right, these are few important points. So see, you can use this as a benchmark algorithm. Like if you,
Going for these two use are best for both text and normal.
Normal thing. Okay. Understood, right? Things around naive Bayes, what do you do, what are the cases? So I'll give you some questions to you do using both these algorithms, find out which one is doing better for you. Okay, let's proceed to next step. Fine, right? With name base.
How to use it? That is an example.
Name base. I'm thinking. Okay, let's do one business case. Okay. Everybody is always happy with. Okay. So I think yesterday I was doing this. This is bank. What was this problem I forgot? This is bank. This is a good case. Okay, this is bank data. Okay, most of your bank account is taken into consideration. Okay, just kidding. So you have how many data? 4521 queries. Right. So you can see. Let me load the file. Bank data. Bank CSV. I'm loading the head. You can see age, job, marital, education, default. So what you are trying to predict is whether the person has taken term policy or not by classification.
Zoom it a bit. It's very dark.
Oh yeah. Okay, so you can see here, this is bank data, and what I'm doing here is this is age, job, marital, education, and this what you are trying to predict here is this last column. Yes or no is there, right? You want to predict this. What is this? Why? Why is based on the bank details? You want to predict whether the person will take term policy or not. You know what is the term policy, right?
It's eligible or
You will take. Eligibility is not a prediction criteria, right? It is a rule criteria.
Money, if you have money.
No, it's not the case, right? If he has more money, also he will not take it.
Not take. So it depends.
Depends.
Depends. If the person is single, he might not take term.
He will not take. If married, then more chances.
Right. I don't know how many, but he might be single.
No.
Yeah, interesting prediction. Okay, then what you're doing here, the first thing, as you already know what you should be doing, you should do a info. Okay. On doing info, you get a hang of it. You see some this numerical column, and these are your string info.
even now that null data is there, we can read.
Yeah, you can. In this case, luckily there is no null data. Okay, using this technique, this is I find very useful. Unique. It tells you really a lot about the categorical information. It tell you this is unique. This is a job column. This is the columns area, all the columns. Okay, this is your categorical column. From this you're copying it here. These are all categorical columns. Okay, what do you do? Exactly. What do you do? We are converting categorized information to a number as a part of visualization. Right? These are the columns that we need to convert. Okay, and we are using label encoder in this case to do the conversion. When you use label encoder, you see you are taking that particular column, converting this, and okay, and let me execute. Okay, so here now it has transformed all the data, right? Everybody wants to see the data. Bank data. You can see here all our numbers here.
Yes.
Right. Now, this is a very important aspect of doing this thing, correlation. What you want to do is you want to use correlation matrix. Okay. Using correlation matrix, you'd want to find important features here as a part of featureization. right? What you do, for remember in correlation, the sign does not matter and only the magnitude matters. Absolute value. So that's the reason I did a first absolute value of this correlation corresponding to this y column. We want to, if I don't do y,
no, y is the one which
What is the target?
exactly, y is the target column. Okay, so if I do this, you'll see, it is giving me like age to age, it is 1, job to job, it is 1, but age to job, it is this guy. What we are interested corresponding to this row. Y corresponding to age, Y corresponding to job, right? Okay, and that is why we do this. Okay, if I do this, it will show me only for Y corresponding to all the elements. See? Now, okay, now since the sign does not matter, okay, the correlation matters, value matters, magnitude matters. Okay, so here is this guy.
Well, we can do sort on this.
Because we want to find the important values here, right? So you do s dot sorted value sorted values and ascending is equal to false, so that you increase the decreasing order. If you do so, what do you think? Till this much is fine for you, right? You don't need other things. Since all are numbers, you can find correlation. Okay, so you are interested only in these are the columns. Fine. Feature selection is done. Okay, then I have written here all sorts of classification. Okay, logistic regression, train test weighted random forest classifier, KNN, Gaussian B, right? All sorts of stuff. Okay, then you're initializing the model. Of course, this is not the best way. You can use GridSearch here. That's an assignment for today. Okay, you have to change these codes to GridSearch. Whoever doesn't complete, treats others. Right? So very chances that you will treat given your anaconda is also not installed. Okay, let's see here. You have this classification names. These are the names, right, of the classification algorithm. The random forest, this Gaussian gradient GB. GB is gradient boosting. No, Gaussian name is yeah. Okay, so Gaussian B only. We have renamed it to GB actually. Then you have KNN and LR. All are classification. You have created all the model, initialize them. Bang. Right. After that, this is a very generic function. Okay, in the entire code side, I'll be giving some in many places very generic function. You will see these are very standardized function. You will see them everywhere because a lot of people write code that way. Okay, so even of course I'm not the one who invented this way of writing. I've also seen it somewhere and I've also personally used it. So I'm adding, just spreading it across. Okay, so what using this approach, you pass the model name here, right? Whatever the model is, it pass the model name. This is the data name, right? This is the X, this is Y. What is X and Y? X is your target features, Y is your
data.
X is your
Feature
data and Y is your target data.
Y is target. X is your feature column, Y is your target column. Column names, right? Maybe I can put a comment here. It's written right. X is a variable which will be used for column name. Okay, now what are you doing? Train test data. Data is your complete data. Okay, see the way I'm calling it, huh? This is your bank data is my complete data. Modified one. Model is a model name. For IDX model, okay, in enumerate classification model. Classification model is list of all models here. Did you notice? Classification, everybody has to execute this after the class. Okay, I mean in the break, for the break, just to execute to get a error hang of it. Okay, so here you have this classification models. This is the model name of the model. So every time it will go with different model, right? Bank data is the actual data. It goes to data. Important columns is the columns that we are interested, and y is your target. Fine, right? So every time you are doing this, it is calculating the accuracy and returning here, and you are printing it here. So you're getting around 89%. Gaussian naive Bayes is giving you 85%. Logistic regression is giving you 89%. Understood that process? So use the same stuff. Yeah.
Can you please print the actual output? The actual means predicted. What are the whatever the prediction we got from this?
Oh, I mean the prediction part, right? So I am actually, as of now, I'm not storing the model. Okay, so we can do that with slightest modification.
I just want to see actually whether what basis this percentage is printed.
Oh, this one basis is percentage printing. This is based on the, see, you are dividing the data into test and train data here, right? You are training the model with test data, train data. You are predicting the model with X data. So this is very same code actually. Right? Okay.
Oh, okay. Printing the the model accuracy. Okay.
Right. It is predicting the model accuracy using this approach.
What is that?
Model.fit, yeah. So I'll explain. So this, yeah, I'm just explaining. So this part you understood. It takes model name, data, and feature column, target column. What you want to do here is train X index is your index number, right? You're giving it X here. X is your all the columns, right? So it is it is data for training. So what it is doing, train X is all the data. Lock, this is the index number here. Lock, this is the target data. This is the test data. This is the target. So what is it doing? That you are splitting it first, train text. Okay. Then you are, I mean, of course, you can do it differently as well. Okay. And when you do this train y.values.label, right, it actually converts them into one-dimensional array. If you do train X values, okay, it consists of two-dimensional stuff. Okay, because here you are getting by data frame ways. Okay, if you do label, it is converting two-dimensional. Like you use reshape -1, right? It is reverse of it, label. Okay.
Last time we didn't do all this, right? We just used train X.
You can do train X testers, and you can do that as well. Okay.
And then what is the difference between this splitting and the initial one that you're doing while importing the data X?
So here, the separation of data is also happening. Actually,
no, not this one. The train underscore testers to split, right? That function. And
there you have separately given up X data, Y data. You remember, you train test split. We have two data, X, Y. Then some ratio you would have given.
Yeah. Yes.
Right. Here we are giving the complete data. And from the complete data, right, train and test it splitter, right? Train data and test data. Then it is dividing the columns.
So, Avantik, we are here training X data separately, Y data separately, right?
Right.
The thing is that Y data is a target variable, or is it kind of same as variable as X?
We are not training X. Sorry, Y. Training is expected, right?
Yeah. So in case you're finding it a little confusing, I can rewrite it in a separate way. Okay, so what you have train test split, right? Train test fine. This will have it. Then train X test X train Y. Test X spread test Y. Is everything right? X and Y you are giving your training. Huh? Yeah, everything is right. Okay, this part is clear. In case you find this confusing, this is the same stuff we are doing here. You're getting your passing X and Y data. You're just based. It becomes very generic that way, right? You can actually, if you want to predict the gender. Oh, wow, that will be interesting. If you, I mean, of course, you have to do. They do this. So you want to predict gender. You find marital status based on the other information. Right, you don't have to change a lot. I mean, this sort of exercise, you just have to change the value of X and Y and everything will work seamlessly. Okay. Clear, right?
I want to think if there is like a negative correlation index wait, if there is a negative or positive correlation index between these features, right? Then it's okay. If there's no relationship like coefficient thing is 0, then it is kind of no op, right? There won't be any prediction. I mean, even though there is a prediction, it will be very poor prediction.
If their relationship is not linear in nature, right? You will use different algorithms. Then your random forest, there is a linear, there is some echo.
I think someone has.
Is it fine now?
Yeah.
Okay. So here, what I'm saying to say is, if this is working decently good, like logistic regression, that means it is linearly separable data. That is what we understand about the data without even plotting and all that, right? But suppose it is much more. I mean, this data is of non-linear relationship. That means if one grows, the other doesn't grow. Okay, if one grows X, other is going sometimes 10X, then it is not growing. So there is non-linear relationship between the data. In that case, we'll see random forest is doing better. Okay, so when we come to a random forest, we learn that why is it so useful in understanding non-linear relationship, and that is where your neural networks, unstructured and data, those things fix it. Non-linear relationship.
The many data will be make sure that it is a non-linearly separable.
These algorithms will tell you that.
So you have to do all the steps and then only you get.
Yeah. Sometimes you might have some idea about it by plotting some graphs and all that. You might know something, but sometimes even those may be incorrect.
Time consuming, right? So if it is like data.
No, definitely it is time consuming. That's why people will pay you, right? Got it, right? I mean, that is where data, it defines a lot of stuff. If the data is simple, I would say this is a simple data, right? If it is much more complex, convoluted, and not so intuitive, it will need those sort of stuffs. It will need that time. Okay, and you can see there is really no shortcuts. You have to do those stuff, then only you get to know. With experience, you might build up something, but the way to get experience is to do it first. Understood, right? This whole drill that we did here. So of course you can do naive base. I mean, the usage of it doesn't change.
Can we see for structured data it is linear regression, unstructured data it is random forest?
You want to see where random forest is working well, right? I mean, typically you want to see for non-linear data, right? This house price was your not house price, your employee exit, right?
What I'm asking is, for structured data, directly can I apply linear regression?
You cannot have these rules. I mean, yeah. I mean, if you have a prejudice in your mind that what this thing, you are not doing justice to the work, right? I mean, when you're doing experiment, you should not be biased. Right, have that open mind. This might also be that much. You do that. Start with a benchmark case. That is why the basic algorithm comes into the picture. It gives a benchmark. This is where everything starts. Minimum you should get at least with this is very small minimal code. If you can do a lot of other stuff, you can reach 95, 97. Okay, so I can say yes with my simple example. I can have a benchmark code of benchmark accuracy of 89%.
So if you have a large data set, what you detail file use this algorithm and see if it is working.
When first we do some plottings, then correlation.
Yeah.
To see the correlation between the data.
It's like I'm given a large data set and I want to fit some card. And how do I approach that?
That thing, right? That is very similar to how this problem was. In the beginning of it, we had just bank information, right? We wanted to find out if somebody will take this policy or not. We don't have any information. What you first do is, I mean, even I didn't. This is yesterday, just 14 hours ago. Okay, then I didn't know anything about. What should I do? Let's find some important features out of it. I use correlation matrix. One of the approach. Okay, found some important features. I took just top 5. Forget about it. I just need a base model. Okay, top 5. I just mentioned few algorithms. So as you can see, rather than doing experiment separately, I'm mentioning these algorithms here itself. Logistic regression, random forest, KNN, Gaussian NB. I mentioned these algorithms here. In one shot, I'm trying it for all of them. So I'm getting for this algorithm, this is the accuracy, this algorithm, this is the accuracy. So we've got some numbers here. That, at least logistic regression seems to be reasonable. That means this data is linearly separable in nature. We got some understanding out of here. Then I might do some more processing of the data, some more different encoding, some more iterations, right? Some more grid search techniques to tune the parameters for logistic regression. We might actually use some normalization and we might get some better results, right? So that is the process. It is actually iterative in nature. Okay, you cannot really say, this is all I have to do and I will get the result the way we do in Java or similar stuff. Okay, you have to repeat this process.
But at times if it is 70%, we use gradient boost. We come to 90%.
Not necessarily.
I mean, at times. So we don't go for the next algorithm. So it is again a
no. I mean, if you are 90% and you're, I mean, it's not that case, right? You are getting 90% and that is for this data. Then you get some more data, you keep validating and your, accuracy is getting reduced or it's not acceptable, right? Then you try to fine tune it more, not just with algorithm, but with parameters, with hyperparameters.
In real world, how they do this?
Yeah, so this is the way. This is the way. Just that you'll be doing these things at a higher scale. Okay, what they do, they give a problem. Okay, I mean, as you studied, right, how we did was like many problems. We started from scratch. We don't know anything. Okay, maybe we can take up one problem and do it. Okay, we don't know anything about it. From that stage, how do you really conclude? Okay, of course, in 1 hour or 40 minutes, it will be difficult for me to, get the best of the results. But we can get the benchmark result. This is known as benchmark result, 89%. Okay, that means if you do fine tuning further, you should at least get 90, 91, 92. Slowly, you'll see you're improving. Okay, so that is what I mean. You have to try for a lot of cases based on. In this case, I knew that this guy. Sorry, in this case, I actually didn't In case of other previous examples, I knew this might work better. In this case, I have no idea working on banking data earlier, right? And so it was like in Jane. So all I did was I made sure I took important features. That has worked out for me. Okay, sometimes it might not work out for you. Then you might have to use random forest for finding important features also. We'll learn that in the next class. Okay, got it, right? When it is non-linear data, then you might have to use linear random forest to find important features also. Right?
One thing.
Uh-huh.
No, okay, I understand. Okay, this works very well with the language processing, right? Text processing. But what about the image processing? So image features are totally different from the text processing, right? So will this algorithm work well with the image processing as well?
Image processing, this guy will work to a certain extent. Image processing, you have to rely more on neural networks, CNN.
Okay, because you get the pixel, there's nothing but a matrix, right? The ampersand
So we
matrix.
can do some sort of image processing with these guys. Okay, actually, we can do some name base for. Hey, did we do handwriting data as of now?
No.
Sure?
Yes.
Huh?
Sure.
No.
I am not trusting you. Just kidding. Okay, just kidding. So let's do this handwriting data. Okay. Okay, so handwriting data is a very similar image processing data. Okay, we might not get very good accuracy, but we will get decent accuracy. And if you use neural networks, I can show you result. We have 98% accuracy as well. I'll show you before we get there. Okay, so that you know why you need advanced concepts.
Neural network and deep learning are the both of the terms already used.
Deep learning is extension. I mean, implemented using neural networks. Okay, so one thing leads to another. Neural network. I mean, that is part of next course. So I'll limit the discussion here. But what do you do in?
Avantik, I'm sorry for that. I got interruption for 5 minutes due to internet connectivity. Can you please tell me what the things you have explained within 5 minutes?
No. We are about to start handwriting data detection. Actually, okay, we didn't start.
Okay. Thank you.
So handwriting number recognition actually, yeah. So this I used neural networks, I think so. Let me check. This I use neural networks. Okay, you can see I'm getting 98% accuracy. Okay, and we'll try now 98%. And this is huge. Actually, this is huge data. This is 55,000 data with 28 cross 28 pixel image. You can see this. Okay, what will we do now using scikit-learn is just very smaller data than this. How you want me to do with this data? Let's do this data, but I keep my fingers crossed for the computation. It might be a little too much. Okay.
So what are you using for this one?
This is a neural network, deep neural network.
Yeah, what do you use?
For now, we'll use all the classification techniques that we know. Okay. Let's first do it.
Use another.
We'll start from here.
Another case.
No. This I cannot use. This is neural network. Okay. This is known as MNIST. Right. Remember this term? Okay. Okay, I know the smaller version of the data, but I want to see if the scikit-learn provides you larger data, or I will do with smaller data. It will quickly happen, or it takes a lot of computation. I can give you an assignment to work on the larger data. sklearn Oh, nice. Okay, so if it takes time, we'll go for T. Okay, let's load it. This is our huge data. Data.
It's not connected.
Why is it not loading?
It's loaded.
Oh, nice.
Loaded.
Okay. Okay, so you can see it has the data, right? So if you want to see the data, if you do data, oh nice, it is 70,000 data, 70,000 images. Each image is of 784 size. You know why it is 784? Okay, 784 because each dimension of the image is 28 cross 28. Okay, 28 cross 28 is 784.
Okay, you're talking about in this data set, right?
In this data set, the image is of 28 cross 7. You don't trust me, right? So let's see the image first. Okay.
And all are grayscale then.
Huh?
All are grayscale images then.
Grayscale images, like black and white images. Let's see the data. Import mat.lib .python as PLG. PLG. Okay. Yeah. Okay, so you have this guy here. Okay, now what you intend to do here is okay, we want to see one data, okay? Okay, see, this is the entire data. So this is one scale, grayscale. So this grayscale data means it will be only one color. Each number will be 0 to 255. Okay, so now you want to see the image here, right? Okay, then plt.imshow. I think C map is equal to something comes, but at least you can see this is 0. Understood? Okay. Of course, it is a color. It's a color and white. So C map is equal to something like that. Once I forgot. Okay, you can configure it so that it can show black and white. I am little lazy to check. Okay, so you can see this is a black and white color. You can match.
So when we get a data set, it will be converting it into numbers.
So whenever you are getting an image, right, internally this is actually, before machine learning could process it, it needs to be converted into numbers. Okay. Now you have such data set. What is the first thing that you do? You divide the data into two parts, training test.
So no, 1 second. So when we get an image itself, how will we convert it normal, the level encoded or something else?
Image, if you are getting a raw image itself, right, there is actually I showed, I think, once. Okay, you can convert it into a NumPy data structure. There are functions using which you can do that.
I'll show you using which we work now, the strings into
numbers.
Text data into
once I did that actually. So yeah, just one function you have to use.
Label and call.
No.
Text.
I use one function. I've done it in one exercise. Pandas or anything. I'll show it once. Okay. Just one function call, and that will convert that into NumPy. You just Google, you forget that. Okay. So here also, if you see, you can find it, or else it is known as just one name is there. No, that's distracting, but just one name. I'm just seeing if I can find that, or I'll tell you after. I keep forgetting that is very not so obvious name. Image identification. Let's see. Why is it so hot? I'll show you. Okay. It's just one function which is just convert into numbers. Any JPG image, right? It needs some external library actually. Just import that stuff and just do that. That's pretty much. Let's come back here. So we have this data, right? So what will you do first? You will divide the data into train, test, fit. Okay, and you have label information also here. If you want, this is map data, right? Just you can see here the label information 0, 1, 2, 3, whatever is the label, it is printing you there. If you do a shape of it, what will be the shape?
Like 7,000.
Right, 70,000. Okay, so target. What is my target information? So what you need to do is we need to convert this, right? Train, test, split. First data is this, then target data. Okay. Train X, test X, train Y, test Y. Okay, it created this stuff. Now, which all are numbers, right? Okay, so you want to use a model
libraries.
Use all of them, or so first we'll try with simple one. All of them, I think you can write that code, right?
This is classification because
you have to identify, right?
If it is 50, if it is 0 to 50, then what do you use?
What are the targets?
0 to 9 only, right?
Yeah, 0 to 9 only.
I'm asking if it is 0 to 50 or the predict.
No. It will identify digits character. You write 0, 1, 2.
But again, the target will be like a continuous function, right?
No. Target will be for each character, each data it is seeing this, it will have to tell this is a 0.
So
if it is 2 characters, each character will be represented as, if you represent each character, will be 28 cross 28. So 55 will be represented in 28 cross 28. 0 will be represented in 28 cross 28. Okay. So we'll take one data and convert, say this is 5. Next data say it is 0, so it is 50.
But that's not asking. So the target values are getting continuous, right? As the number of
target values are fixed, right? You have to just do character identification. When suppose you have to write a software which will read out English text to computer as a digital text, it has to identify A and write it A here, B and write it B here, C and write it C here, right? But automatically the string will be creating over there, right, in the memory.
So for example, 50. Okay, so in that case it should predict 5 0.
It should predict 5 and 0. That's all. Its job is done. 50 is up to the computer to interpret that 5 and 0 is coming next to each other. That means it is 50. Oh no, you didn't get it actually.
I got it. Then you have to concatenate these two connections and make it as 50 like that.
I mean, see, suppose somebody has to interpret this handwriting. You will not write an English word understanding stuff, right? Sorry. Okay, you will not write an English word. You will just character identification. Once a character identified by the software, it will write this line. It will convert into English text in the software. The job is done, right? After that, it is the next application. So here the role is to identify 0. If you write 0 just like this, it should identify this is 0. Right? Getting meaning of 0, 5 and 0 together, coming together, what is 50 or 500, whatever is it, it is up to the application.
It is a classification.
Classification. It's a classification. We can use both of them and see how it is going on. You understand, right? Possible targets are 0 to 9. Models.
So the image is 0.
That image is 0. You'll have dirty numbers like 6, 7, nasty stuff. Our eyes won't be able to interpret, but it might actually do it correctly. Okay. So what is the name? Name base. Stage regression.
But before this, we have to import these libraries and the.
We'll look for just writing all of them. Random forest logistic regression base. Fine, right? Multinomial logistic base. Oh, somebody's eating.
That's me, sorry.
People are hungry here and we're eating. Okay, so
For me, it's kind of midnight, right? 12, 11.
Okay, so you have Gaussian naive-Bayes, random forest logistic regression in place of multinomial naive-Bayes. Okay, so models is equal to.
Can you give the naive-Bayes this one also? Gaussian naive-Bayes also?
We can give that. Okay, now all are numbers.
One thing save model as well that we can get that matrix and print the image. Okay, how it looks like.
The output.
Save the model as well so that we can get the output and print the image.
Okay.
So compare that how so okay, whatever the percent loss, right? So we can say how it looks like.
Test.
Model name. Okay, so I'll just execute from here. Memory error. Let's test a simple case. What is wrong here? Something wrong. Model is equal to logistic regression. If you do, model is equal to. Wait, did I do fit or what? Yeah. Fit. Memory error. Is it too much? Ensure minimum features. What is it saying? Off. Switch it off. Otherwise, it's not going on. Okay.
Generally, when this
Let's see. You know, if the only thing wrong is train X, train rest. So let's see the shape of it. 52,004.
correct.
I think it's running out of memory.
Yeah, that is what it looks like. I thought. See, let's see here.
I think it looks like it's a leak as well. Anyway, that's fine.
So what will I do?
We can take the subset of the main data.
Subset of the data, yeah. So the reason is my AWS that I'm using, right? That has very less memory. There is something known as train ratio. Here you can configure where there is one parameter which tells you what is the ratio of the training data you give. Test underscore size, yeah. So there is one. Why is it taking so long? Yeah. Train underscore size. Okay, yeah, and we want to give it percentage. It should be between
0.75, 0.25.
So we'll give it 0.25. Train underscore size, right? So we go to 0.25.
But again, test will be more, right?
That's okay. We okay, and at least yeah, that is good. See, these things actually, even with the less memory, TensorFlow does well. Okay. A second.
While importing SQL, we can take the first 10,000 columns to 20,000 columns, right?
Yeah, we can do those stuff. Backtrack some piece of code. Okay. So here,
0 to 20,000.
Okay, so good accuracy, right? Lost regression, still too much. Who is winning? It's very close to actually call somebody winner. Just remember, we are using very less data here. Okay, and let's see. Try to change it a bit and see if we can get better numbers. Okay. Yeah. So it's clean code, right? You have train data, test data, separate. If you use the lesser size data, like this 28 cross 28, so more information is available, right? If you use lesser, like we have another image data with 8 cross 8 image, same data, image data with 8 cross 8. There we never reached this 98. It was on 92 sort of a thing. I think I have the code also. Let it run. I can show some similar stuff. So this was random forest. I think I was using random forest to explain Mr.
If we use linear regression in this just case, will it throw error or will it still cut?
No, but in the training data, we didn't provide any continuous output, right? Which was only fixed numbers.
Still 0, 1 to 0 will be taken as continuous also, right? And if it is 1000, then it will be 1000. That's what I was asking.
But if you have just a second,
Yeah.
this is your digits data actually. Okay, so here it is 8 cross 8. I think what was the accuracy we are getting? 90 only. Oh. With random forest we are getting, I think 95. This is the confusion matrix that we got printed. Keep
So it was same, right? Other things as well.
Right. So it's still executing now. For small data, I did it fast. I don't know if not as a control system. Just responding. Yeah. Okay. So coming back to your question. So if you have, you're saying that you want to solve it, you can do that. And if you want your output, right, target. In case of target, you have 0, 1, 2, 3, whatever is it. You are not telling that this is 0, this is 1, this is 2. Right? Based on that feature, it is predicting this to 0. You can do this with linear regression. Okay, but the output you will not get. It will be 0.25 sometimes. Okay, so your 0 data is getting classified into 2.25, but it's not really a case of classification. But you are doing it, you will get some result, but you don't know how to interpret it. You will not identify that this is 0 here. That sort of conclusion you cannot make. So see now, Gaussian naive Bayes has come to 73 and multinomial naive Bayes is 93. Better than that. Random forest is anyway superior. See, increasing with lesser data, that is what with lesser data, if you're including something that is not right. More data you see, what do you call that in Hindi? Dudh ka dudh, pani ka pani, right? Something that is what is happening. Okay, so lesser data can give you wrong intuition, can give you wrong understanding, can give you incomplete stuff. Loss regression is also really good. Okay, let's take a break. Yeah, guys, let's take a break. Huh? Oh, it's already 12. Let's take a quick break, 5 minutes. Okay, I mean, we'll meet at 12:20. 5:30. Okay, we'll wrap it up by 1.
Avantik. Hello, Avantik. Yeah, could you the next part? I got bitter interruption. Then after that, I couldn't able to record. Could you please this upload into YouTube, right? These things.
I'll do so.
Okay, thank you. So we'll come at 12:20, 12:20 or 12:30.
No, 12:20.
Okay,
so
thank you.
One more stuff so that we can get.
Sure.
Avantik, what will be the content for next half? Continuation of this or?
Right. I'll proceed around. Say, I will not be starting a new topic. It will be mostly doing some exercises involving this. It might be late for you. If you want, you can drop off.
Yeah, I'll drop up today. Tomorrow at 8.
Tomorrow there is no class actually.
Oh, excellent. Okay,
Yeah,
that's fine.
Sure.
Okay, I have a lot of homework from you then.
Okay. You remember the other one as well, right?
Yeah. Okay, sure. Thank you. Bye.
Chalo, have a nice time. Have a nice weekend.
Okay, bye.
There's no class.
Huh?
Tomorrow there is no
Tomorrow
class.
there is no class. Tomorrow actually. Yeah.
Next Saturday,
Next Saturday.
same at 1, right?
Yeah, just actually I enrolled for AI. So I came army, but
For AI, this is important.
all these are related only.
Yeah, this is the basis of that also.
Actually, AI algorithms only used. AI.
I don't know what is our neural networks. What is it? AI. It's a very vast topic. So this is the basis of it. You should know these things. Not sure about AI. This is machine learning is already a part of it.
Sometimes people get confused.
What is?
Yeah, I use automatically. What is data science? What is machine learning? What is AI? And interestingly, is
but it's different actually. Only the persons who actually really know about this thing will be able to differentiate it. For me, still AI is a part of it. Machine learning is a part of it. What is it?
I'm working at Excel. Currently, actually, not a student.
Adobe work? Adobe, which office? Which office?
Bangalore.
No. I was in the train actually.
Actually, my room is near the Subramania. First, near Subramania.
From after that.
Yeah, after one housing flats are there. Shobha. Shobha apartment.
There is a okay. From there you have to go straight. Then that.
How long you are in Bangalore?
3.5 years. That's it.
2 years.
Yeah. I don't read a very well. How it's like my home.
Past. So the time since I came here, I didn't went to 2 years.
Where are you from?
Assam.
Assam. I studied in Silchar.
Yeah. How did you go?
Yeah.
How did you go? I studied in Sikkim.
I studied in Silchar.
Oh, I also studied in Sikkim.
Which one? Marathi?
Yeah.
Which was?
2000.
Well, you were in BTech?
Yeah, BTech.
I did MTech there.
Okay.
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 Which was?
Easy.
Easy. Hey, I have taught easy also there. It was a dual batch, huh? So I was there in 11-13. So dual means you were joined. Only you will pass out, right?
Yeah, yeah.
So your seniors have a bit top. And that all the labs, they are taking class also for them.
Okay.
Because this guy, Madhu is there, right? So I know the seniors that. MTech I was studying batch. So teaching there. Very good.
Yeah, I was also in teaching. After passing out, I think actually this was not a plan.
Okay.
Teaching in college.
My bachelor was still teaching in NIT. Where is it?
Yeah, one of my friends, like, Mayank, his name is Mayank.
Mayank, yeah. Mayank is.
Yeah.
I have most of the people from this. Maybe not in Huh?
He said short, 12.
It's only 12:30.
He's there still. Unless he say.
So after the teaching for 2 years, then to Bosch, 1 year, then switched to Excel.
Okay.
Then I got exactly now.
Okay. Kaushik,
Yeah,
Russia.
yeah, all those guys.
Yeah.
Avantik,
I last winter.
No, still he didn't.
hello. Avantik is not there.
No, he's not there.
Oh, okay, okay.
With various guys working with me.
What was GS when you were there?
GS was what was the name of the no, I remember. It was when Bihari guy was there. Too much problem was there, no? 2011.
Yeah.
Too much problem was there. Next year. Oh no,
After
he came out.
I was at 12:30. 2 years. So I know that guy. As my friend,
Music secretary, GS in your time was from my some of Zekelabs. We used to teach together. He went for civil services. I think he's here. After that, now he's section engineer.
Okay.
Section engineer posting, I don't know, maybe the reason. You know him from there?
Yeah. I mean, I don't know if I've seen him in the top.
You know, I think that is a big history.
Can you show one? But I was in 7.
Okay, so now we want to see the output, right? So train model is there, so we want to see for last model, or say for last, using the last model. Okay. This is the random forest, right? Predict. We'll pass here one data. We'll see what the data is. Test data. Okay, test. So 5,000 data it has. This is one data, right? Test x0. If we want to see what does it look like. Predict
Test X of 2.
Okay, actually that is happening because you have to pass your list of data. That is how you have to do. I mean, two-dimensional stuff, right? It is predicting it to be 0. But what do you think really it is? How do you print it? That's 0, right? So you're accurately doing in that. Yeah, test is actual data, right? This is a predict actual data. So if you see, it is 4 is also this. It is 1, right? Code 31. Correctly predicting. If you want to see how does text data look like, you can do this.
No, not the 431. This is just an assignment. We have to pass entire.
No. I want to show the content.
This is only the index.
Oh, so that is no. That is because I haven't reshaped it. Whenever you are doing a, I'm sure, right? You have to reshape it to 28 plus 28. Okay. See this. This is 1. It is able to identify this is 1. Good, huh? So machine learning algorithms are not that fake, right? There are some complex things which eyes cannot identify. This guy is doing it.
5, 6, and all.
Yeah, 3, 8. This is also easy. Oh, 5,000. Huh? 3931. 3931. This looks like handwriting, right? Okay, got a hang around how to use these stuffs, right? If you have to find accuracy of a model, you calculated this, you can, and if you want to calculate confusion matrix, you can do that also using the simple stuff that we have seen in the past.
Can you scan something like one, give it, and
provided you are doing this image, I'll show how to do that for image.
It's in the same place. Right?
This is actually converted. This is a converted data, right?
But I can convert the
JPG into that. That is what I want. I'll show now. Okay, how to convert JPG into the question here. I've done it in the past. Okay, just that the function is not very intuitive, so I don't remember it exactly.
Avanti.
Yeah.
Hello. Yeah, actually, the things we are doing in Jupyter. So, if we are performing prediction and analytics in this kind of tools, but if currently I have a system, I have to integrate with other. I mean, currently I have a system. For that, I have to use this data analytics. So, how can I integrate this, or how can I combine these things? These are two different tools, because suppose I am using Java web application over here, for example. So that web application have to show all these analytics kind of thing. So how can I integrate these two? Is it possible?
Yeah, of course. I mean, depends what you want to achieve. For that matter, if you say this here also, I'm running it in a web server only. I'm not running in my local system.
Okay.
Right? All this my application is running in the server. This is AWS server. Okay, as of now, I'm just using 1 GB RAM because that is free. Okay, and of course, if you want, you can scale it. You can have a huge RAM so that whatever operation is taking time, it happens fast. Right? Once you are doing these things, this is a production environment. Okay.
Okay. So if I want everything, suppose if you see in online application, web application, if I click something like I have to analyze these things. So when I click, so the system has to come to this, and so for that we have to integrate this tool and that.
Yeah. This can be a This can be a function call from the backend of a web server. If you have designing an application, you click on some button, that may trigger an activity over here. The
Okay.
output get here, and then you will put it to the client.
So for that we have to write a web service for that, for this.
That is your web application, which will be doing the stuff, then which will be calling this guy. This is very simple stuff. I mean, very widely used. You have web application. You like Card24. You want to see some analytics out of it. You click on, you give your own card details. You click on it.
Okay.
The output that you get, from there is basically that what is the price of your car. Some analysis might happen. So this might happen in the backend, prediction and all that. You get the result from your website.
Okay.
Let's see now. I wanted to show how to load images and all. So actually, there is inbuilt image data once. Scikit image processing method. Okay, so you can use this guy to load images indirectly. IM read is also one option. IM show is the one that I was showing you. Image file name test.jpg, and what is the output here? Returns image array, ND array. This is what we are looking for, right? IM read. Yeah, this is the function. Okay, let's see. fk image dot. IM read. Give the path of the image here. Okay. Image name. If you give as gray, it will convert into gray and all that. Okay. So I'll give Felshi my directory have some image. Huh? I want to download some image. Wait. Don't be scared, okay?
Should give this build predict in Zekelabs?
Image PNG, huh?
If you give this build predict
It
Zekelabs?
can, it can. Not with this code. This code only understand digits and writing. We have to train it for characters.
We can do that.
We can do that. Okay, but before that you have to do some stuff. Okay, so here. Okay. Data.zekelabs.png. Got numbers, colored image, right? I think it will be in shape. That is because I didn't mention that percentage, right? Matplotlib. So I have to rewrite this show stuff. Done, right? And you know how this number stuff. So you can, finally, essentially everything is numbers.
Zeros and
So we can
use this, it will either predict 0 to 9, right? Only numbers between 0 to 9.
or current algorithm.
Right.
So if you get some data from outside, which is of size 28 cross 28, okay, as gray is equal to true, let me write. It will show a grayscale image.
Can you see the results? What happens if you give the alphabets instead of numbers? How it behaves?
It will not work actually, but
Yeah,
okay. But it will not make a lot of sense. Right, this is grayscale. Right, this is the same. We can actually do a C mapping and all that, but this is grayscale.
This is 1/728.
The shape we don't know. We have to see. Because it is mentioned, yeah, something more. Data. 200 plus 28, 200. And actually it's 200 plus 20. I remember I made that.
So if you give the first, I mean, this data to the algorithm, what will you predict? Any number which is 0 to 9. Can you just see that?
It will, you have to first, the shape is not right.
That's why you have to reshape it to.
Yeah, maybe you can, chop up some shapes.
Or crop it one particular.
So, I mean, it is not yet ready to be consumed that way. Okay. But what you can do is, you can take up some, you can write using the same code. Okay, you can identify cat is a cat or a dog is a dog. That you can do. Finally, it is classification, right? You do this.
Download many images and do it.
No, there is a popular data set. Don't do it. Okay. So, not using this algorithm. Okay, you have to train the algorithm separately. Okay, I'll show you. This is 32 cross 32 images of all these categories. You see this dog, right? They have a word of dogs. After this, if you give some dog of this particular image size, it will be able to identify that this is a dog. More or less, if the training. This is used in deep neural network systems. So, but the problem here is data is huge. I don't know how much. Let me try. Okay, not committing anything. Let me try. Identify even all they are doing. I'll use much simpler data set. Okay, this is little loaded ones. It will need 161 MB. It will take a lot of time. You have any photo of yours? Anybody? Two photo. If it is same or not, that we can do. If you have two photos, it will try to predict if they are same or not. If they don't change the orientation or not. You smile, you don't smile. It will still identify this person is same, this person is same. Okay. Those complex things you will be able to do with deep learning. Okay. So there is a popular data set of US presidents. Okay, inbuilt. Let's use that. So if it is more around images, this guy will actually, show you more stuff. This guy.
Hello. In some application, there will be a capture detection of image. That is also same kind of machine learning problem, is right?
No. That is quite different actually. Okay, because captcha is a different game. It is security. It has to change. So not much to do with this.
Whether in that they will ask whether this is robot or not. So that is also classification kind of things, right? In the captcha, they will tell us to click on the images you will find. So that is whether you are robot or not. That is kind of machine learning or something different, that one.
Yeah, but I mean, of course, I mean, there is that they are trying to identify if you are human or a robot actually. Okay, that is whatever you are selecting, how much time you are taking, and all those parameters. I mean, you cannot much correlate actually. Okay. Huh? For that is normal validation security stuff. Of course, I mean, little bit of those things, but I mean, it's little too far to compare. Okay, I mean, no. Machine learning will be used to attack it. Got it, right? You will be using machine learning to create a bot which will attack that, which will try to simulate as human, not the other way around. This is ulta of machine learning, right? Okay, I think this is the one. Okay, these are the images. It can, but this is not the best algorithm. So this goes unstructured data. If the kid is like this and it becomes like this, tilted, right? How will you identify it? I'm telling you. I'm saying you. If it is same posture and all, it will identify these pixels are same. Eyes may be same. It will be able to identify that. But these stuffs are not capable of doing that. That is where your deep learning comes into picture. You still get some accuracy. You will get. So it's not be that bad, but you need more accurate results.
that is it.
I'm seeing if I get president, the US president data set is there. OVT phase data set. Let's see what is. Okay, so let's see this guy. It will actually download the data. Okay, and this is the what it returns an array of shape. This. Okay, we'll see the data. Huh? This is the data. Actually, I haven't used this guy. I've used something US precedents. This is not US precedent. Only with I don't know. From okay, so let it download. Oh, description that way it is here, right? So you have data, images, target, descriptions, right? So phase data dot target 400 images total, right? If you want to see the data, each image is of 64 cross 64. I don't trust this guy. Let's see the data. This is already in the width comma. This way you don't need to convert it. You can directly. Oh, what happened? Oh, right. A lot of data, right? So you have want only one of them. Yeah, not 400. 400 is the number of images. Each image is 64 pixel cross 64 pixel.
400
Images.
400 images.
One image.
Face, right? Okay. So what is the data set? It is like, loader. It has kind of 10 pictures, each of 40 individuals. So 40 number of classes are there, and so let's see. We want to see the contents of it, right? So we want to know who is this person. Any idea? It is class this guy. Target names or what? Data.
There's something on description.
Hmm? We have to open this URL maybe, but still, the images were taken at different times, varying light expressions.
Smiling, not smiling. Different types of them.
Okay, to learn a little more about the data, so let's go here. Somebody is cheating us. Let's go here. Dear God, what do you mean? Here there was the link. Here this was the.
No, that means it has taken there also.
Yeah, so here our database for faces from the ORL database for faces contains a set of faces images between and This database was used on 10 different images of 40 different subjects. Right. For 40 different subjects. That means number of classes is 40. Where is that? So, oh, they don't have target information, do they? Target. Why are we not seeing target? Are we seeing target? Oh, the names are not there. Only target is there. Oh, target is there. Okay, so what are the possible targets? 40 classes, right? Okay, so what we'll do, we'll try to predict the target. Okay, let's assume the name is not there. I mean, they could have given to us, but 40 different people, some lab assistant, some experiment, 40 different people, 10. So we'll identify, what are for this particular guy, what are the photos? For 0 guy, what are the photos? For 1 guy, what are the photos? That sort of thing we can do actually. Okay, so let's create our model. Ready? I'll use the same code. Okay, so phase data, right? Hey, how much was the data size?
Data size is
Why is it? Oh, anyway, even if you're given that, it would not take beyond what you are saying. Fine, right? Let's see. 64 into 64 is
not that fun.
128.4096.
What is 64 into 64? 64 into 64. I think it is correct only. Correct only, right? It's correct only. Okay, so let's now create all the models and then validate it against them. Oh man, it's very hot. This is your train models. Okay, this is your I know. images. Even if it's small, it takes time. Okay, because that is where your deep learning and all those things, because images are very computer vision.
Yeah.
The subject, if you specialize, it is part of computer vision. Got a hang of solving this stuff, right? With image. This is just 400 image. Oh no, gone. And might have to
If I had to, after getting this one, I had to pass, I download some image and pass it to this. What should I do?
you have to make sure it is in the same dimension.
So reshape will go
Reshape, no, you might have to crop it up also. It needs this model is trained with 28 cross 28.
Okay, then I can go to Paint and do the research and all, and then I can import it.
Right, you can do that.
That's it, right?
That's it.
So any of this 40 will be coming up.
Right.
The only thing is that I need to change the resolution of that program.
You can train with the.
So is it like resolution in pixels only? Whatever is showing?
Got it, right? So let it load. I'll upload it when it finishes. Okay, in extreme situation, what I might have to, since it's a low-end machine, I have to restart from my AWS accounts. Okay, so what I might have to do, I might have to this is one of the things that you do in image processing, compress it. It's just 64 cross 64. What is general size of images? 1024 cross 1024 is a norm, right? Think. Appreciate all the systems that is working. It may take some time. Okay, I'll upload it. So tomorrow there will be no class. Okay, we'll meet next week. I'll highly recommend you to solve some problems. The solutions is also there in GitHub, but before looking at it, okay, try to solve the same problems that we discussed last time. Predicting number of comments, right? Then finding out the same example that we did for bank case, right? Okay, then food related food analytics, right? That review comment using food. Those problems are there. Try solving it.
We will be having on next Saturday, right?
Huh?
We will be having class on next Saturday.
Next Saturday, right? Okay, dataset is mentioned here only. Actually, no problems. The UCI website, that is a good enough source. UCI, wherever I pick the data from, right? UCI.
Some Amazon.
Those all.
That is from Kaggle.
That is from Kaggle. Kaggle, UCI, these are very good data sets. Okay, there is no shortage of them. You can see this. This is Amazon food reviews. And so getting a hang of the thing, right? I mean, how is the learning so far? I mean, able to solve problems, pick up the stuffs, get a decent accuracy, right? Yeah, there are of course various categories of problem. So able to solve some mid-level problems now. Okay, and one. Let's stop the recording.